And the next thing we want to think about is transitions. Right now we're transitioning with a 1 second delay. That is just for testing. That's not really how our mechanic will work. So the way that we want this to work is transition from idle to syncing. We want to do what? We want to detect, let's say detect if actor enters the trigger box. So if we're in idle and this condition is true, then we will transition to syncing. So while we're in syncing, we want to transition to rising, right? So then you have to think about it. What is the condition that needs to happen in order to go from syncing to rising? There are no more actors in the trigger box, right? We were on the platform, we start syncing, and then we jump off. Well, then it should start rising. Now, if we're in rising and we want to transition back to idle, then we have to think about what is the condition we want. We probably want to detect if we have risen back to start position. And there's actually one more transition here because right now we're going in a loop. We're going from idle to syncing, syncing to rising, rising to idle. But we could actually go from rising to syncing as well, right? We want to think about all the possible state transitions that we want. And this transition will happen if we're rising and a new actor is detected, right? We jumped off the platform, we start rising, but then we jump back on before it gets to the top. We want to start syncing again. So these are going to be our different transitions that we're going to plan for. We're probably going to have even more than this, but it's good to just sit down, try to type it out and get a plan going before you try to start connecting nodes and blueprints. You want to work towards something specific. Now, in order to do this, you can already see one of the main things we need to do is detect if the actors have entered the trigger box. And we're going to create a custom task in order to do that. Now, before we start creating tasks, I want to talk about the difference between a global task and a state task. Now, both are just a task. It just depends on where we assign it. So for any functionality that we want to run, no matter what state we're in, always be running, calculating something, whatever it's doing, we want to assign that in the global tasks over here on the left. So you can see we can assign a global delay task or debug or whatever. Now this will run no matter what state we're in, but if we were to attach a task to a particular state over here, it's only going to run while we're in the state. So sometimes you might want a global task and sometimes you want a state task. I want to create a global task that will determine if an actor is inside of our box collision or not, right? You already see how prevalent this condition will be in all of the different states. So I figure let's just make a task that will run globally all the time and always just tell us if we have an actor overlapping or not. And any state can just look at that and then respond however it needs to. The other thing I want to talk about is a few keywords that we're going to need to know about when we start building out our task and blueprints. There are 3 primary keywords that we're going to use that is going to bind our different variables in different ways. The first one is context. We've already encountered this word already. If we use the word context when we're inside of our tasks, this means that we're referencing the blueprint owner, right? We marked our BP_weighted platform as our blueprint owner already as context. So if we create a variable and we label it context, this is going to assume that it is the owner of this task, right? So that'll reference our blueprint weighted platform. And these are all categories, which we'll get to in a second. But if we use the word input, that means that we are requiring the person setting up the states to assign a value into this variable before we can even compile. So think of this as your dependencies. So if you need something to do your job, so for example, if I make a task for playing a sound, I need to know what sound I'm supposed to play, right? So we might mark that sound as an input because it needs to be provided in order for us to do our task. An output is something that can be watched or evaluated by other tasks. So for example, whether or not we are overlapping an actor or how many actors we're overlapping, we could put that in an output variable, and then other tasks can see what is the value of this variable labeled output. And then everything else, just use them like normal variables. Editable does allow us to customize things whenever we add a task inside of a state tree, for example. So editable, if we mark it, the little eyeball inside of blueprint variables will allow us to put in some optional values when we're setting it up, like right here in delay. It means that we can edit the duration or edit the random deviation. It's kind of like optional customization. So that can be useful to know too. I think I want to make a global task that will get our overlap actor count, meaning we want to detect how many actors are inside of our box collision. And then we can use that value, right, if there's 2 versus 3 versus 1 versus 0, to determine how we want to transition. For now, I'm going to keep it really simple. If we detect one actor, we'll make it sync, but you could always expand this into, maybe if there's 3 actors or more, maybe it breaks or does some other state past what we're going to build here. So let's make our task. Let's go to our blueprints. And because we want most of our tasks to be modular, if at all possible, right? We could make a task that is specific to weighted platform, but I probably want to be able to reuse tasks in other state trees. So I'm going to attempt to make these as modular as possible. I'm going to make a separate folder in gameplay called state tasks. So make a new folder, state tasks. And I'm separating it this way just to remind me that I don't want them tied to the weighted platform. Inside of here, let's right click. We're going to go to Blueprint Class. Underneath the bottom, under all classes, you're going to type in State Tree Task. You're going to see State Tree Node Blueprint Base, and then State Tree Task. We want this bottom one right here. Select. Naming convention is STT, and we want to think about what we want our tasks to do specifically. I want to get overlap actor count. All right, Control S to save. So this is what this task will be responsible for doing. Again, keep it small, keep it specific, and keep it modular if you can. All right, let's double click to open it up. First thing I like to think about is what are the types of variables and data that I need in order to perform the function that I'm trying to do. And one thing that I know that I'm going to need, so hit the plus button under variables, is actor count. I'm going to mark this as an integer. Let's compile, save, so we get our default to 0. Now you remember earlier I talked about the different keyword categories that we're going to use, context, input, and output. The actor count is what I want other tasks to be able to see and watch the value. So I'm actually going to mark this actor count as output. It's very important that you capitalize O and you spell it exactly correct. You hit enter, it should look just like this, and this will bind this variable inside of our state tree system. So it is just something built into the system you have to know about. You just have to label the category appropriately. So we also want our actor, so our context, so hit plus. Actor, I just call it actor. You could call it context if you want, but let's just mark this as actor. So actor object reference. Since we don't need the specific object reference, it'll be fine, right? We don't need to pull anything from weighted platform, but I do want to mark this as context so that it knows that it's the owning actor that we're referencing here. So under category, call this capital C, context, like that. Make sure you spell it appropriately. If you don't spell it correctly, it probably will not work. Compile and save. We will probably need more variables than this, but this is good enough to start. Under functions, you can actually see the different starting points that we have access to. So enter state and exit state. I'm going to start with enter state. So we clicked function override enter state, so we get access to this. And this will run whenever we enter the state to do a task. First thing we want to do is we want to get our box collision and listen for overlap events. So when we begin an overlap and we end an overlap, we want to know about that so we can check what all we're overlapping. Let's do that first. We're going to drag in our actor. So this is our owning actor since it's our context, right? So this is going to be our weighted platform. Now there's other ways to do this, but since I'm trying to keep this generic, I'm just going to do a component search. So I'm going to pull off, say get component by class, and we're looking for a box collision. So as long as our context, right, our owning actor has a box collision, we will find it and we'll use that. So we're going to set the value right here. So let's actually right click and say promote to variable. So return value. This way we're holding on to it so we can use it again later if we need it. Let's relabel this. Whenever we promote it like that, it gives it a bad name, new var. Let's change that. So hit F2, call that box collision. It is what it is. Compile, save. Pull this up and connect it. All right, after that, I do want to check to make sure that we actually found our box collision and that it's valid. So we can do that a number of different ways, but one way you can do it is you can pull off and say is valid. And this bottom one with the question mark right there. So if it is valid, then we can continue. If we didn't find a box collision, we don't want to try to do things off of a box collision reference. So if it is valid, then we want to listen for our begin and overlap events so that we can detect actors anytime that changes. So to hook into the events, we're going to get a reference to our box collision. I'm just going to pull a duplicate over here. So pull off of that, and we're going to type bind event to on component begin overlap and end overlap. We're going to do both, but let's start with begin. All right, pull that up. So if it is valid, then we want to bind to this box collisions overlap event. So on begin overlap, want to run this event. So let's pull off, type in custom, so add custom event. We want to run this whenever we get a begin overlap. Let's give that a better name. Call this begin overlap. Okay. And before we actually run anything, let's set up our other one so we don't forget. So I'm going to pull off a box collision, type bind event to end overlap. Connect that. So the reason I'm doing it this way is I don't want to detect overlap events on tick. There's just no reason to. We already have events that get triggered. So we're just listening anytime the overlap changes, then we'll check our actors. So pull off of this event, our end overlap, type custom. So add custom event and end overlap. Sorry, I was kind of blocking the screen there. We're not running anything off of these yet because on either of these, we actually want to run a piece of logic that will detect our overlap actors. We want to make a function out of that. Usually it's best to do that if possible. So let's make a new function. We're going to call this GetActoCount. So you can see this is pretty similar to the name of our task. We're pulling the reusable part inside of a function, and then we're using our event graph to kind of like hook it up into where we want to run it. So double click my function to go back. So to get our overlap count, you could just pull the box collision from your public variables over here if you want, but I'm going to actually set up a input and output node just to show you a more proper way of doing it. Anytime you run a function, you want to give it the dependencies or inputs it needs, and you want to provide any outputs it needs. So select my function node, go over to inputs and say, what do I need to do my job? I need the box collision because that's what we're going to test our overlap. So if you send me a box collision, so call that box collision, then I can test it inside of this function. So let's change a type to box collision. That's just a name of a variable. So we actually want the box collision type. Compile. So provide a box collision, then we can use it inside of our function. And we also want an output. So hit plus under outputs, and our output is going to be our actor count. So let's call this actor count. Change that to an integer, and then we actually need to do it. So let's think about our approach inside of our function. So again, I like to just type this out into plain English. We want to get overlapping actors on our box collision. Let's maybe remove the owning actor, right? We don't want to detect ourselves. So we're going to remove our owning actor from the array, update actor count, and return. Okay, now that I have it in plain English, let's try to put it into Blueprint speak. So first, we're going to take our box collision, get overlapping actors. This is just a function built into the collision class that we can run. So get overlapping actors on this box collision. Now you could put a filter here if you want. I'm just going to leave it default because I just want any actors. But if you only wanted to detect characters or some special kind of weighted actor or whatever, you could expose this as a variable and plug it in and, make that customizable. I'm not really going to worry about that. I'm just going to get any actors that it's overlapping with. So we're going to get our overlapping actors. This will return an array of all our overlapping actors. So let's actually save this to hold on to it over here. Let's promote to, actually, so we could promote this to a local variable or a public variable, outside of this function. I'm going to do a promote to variable. I think we only need local, but in case other things want to know specifics about the actors, like other tasks want to see if an enemy actor is in there or something, maybe it's useful. So I'm going to promote to variable instead. So this means it'll be accessible outside of this function, which is fine. So we're going to save that into the variable right here. We're going to set it. And then we also want to remove the owning actor. Remember, that's going to be the context. So let's drag this in. Let's say get. Let's pull off of our array that we just set, remove item. And the item that we're going to remove is our owning actor. So if our owning actor is inside of our collision, it will remove it. And then after we do this, we want to get the length of the array, and then that'll be our actor count. Now, it's important that you do not pull off of this node, right? This will just run the get overlapping actors again, and we'll ignore this part up here. We want to pull off of the array after we have removed the actor. So I'm actually just going to pull the reference in over here. So from the variables, so we're going to get overlapping actors, pull off of that. We're going to get the length. Then let's pull our actor count, and we want to set it to be equal to the length. So whatever our length is, we're going to set that as the actor count. Let's connect these nodes in, pull this down, squish it a little, then we can return it. Now, technically, since we're updating this variable over here, we don't need to return it. It's just kind of nice to say that we can grab that if we change our mind later and we want to refactor it. We'll just return it. So it's kind of optional, but I think it's good practice. Compile, save. Okay, good. Let's go back to our event graph. So we're not actually running our overlap actor anywhere yet. So the three places that I want to run it, I want to check our overlapping actors right when we start. So we're going to do this logic. We're going to bind to this event, and then I want to run our function. So let's say get overlap actor count, pull that in, plug it in, give it the box collision. So I know this is public and you probably didn't need to do that, but I wanted to show you using inputs and outputs is good practice. So plug in our box collision. If you give me this thing, then I can do the job, and then it will spit out the actor count and it will update it. Okay, so this should be accurate. And we also want to get overlap actor count. So I'm just going to copy and paste this over here. Bring this up. So when we begin a new overlap, want to get the new overlap actor count. And whenever we end an overlap, meaning that the actors have changed, let's do another get overlap actor count. Now, there are probably more optimized ways of doing this. Fine. I really just want to get this functional and show you a basic setup that is not too complicated, but good enough to work for what we need. So with all of this set, this should update our actor count anytime we begin or overlap our box collision component. And we can watch this actor count, since it's an output value. We can watch this actor count value and we can respond however we need to. What I'd like to do is just type out, again, plain English, what I want my transitions to be. So in idle to syncing, we want the transition to be if actor count is greater than 0, right? Like if there's nothing on it, then do nothing. But if it's more than 0, then we want to start syncing. Our syncing to rising will be if actor count is equal to 0, right? If we're syncing, but then our actor count is 0, that means there's no actors and we want to start rising. Our rising to thinking is going to be if our actor count is greater than 0, right? So if we're currently rising, we have 0 actors, but now there's 1 actor, then we want to start syncing again. And then rising to idle, we don't know yet, right? This is going to be if we hit the original position, but we have not created a task for that yet. So we're not going to worry about this part. For now, we're going to get these first couple ones working. So this is our plain English logic. Let's put it in. Let's go to our state tree, weighted platform. Now, I could just run this task while I'm in each of these states, right? So if I'm in this state, then run our get overlap actor. I just want to run this globally. 1, to show you how to do global tasks, but 2, I think it's just so useful and I'm going to need it in almost every state anyways. So let's just make that a global task. So global tasks are going to be over here on the left, plus, and you can see our custom task, STT, get overlap actor count. With anything marked context, we don't really need to assign it. I mean, you could, but we don't really need to. It'll assign automatically because we marked our context up here, right? So it means that we can get access to this specific blueprint if we want. In most cases, we don't really need it. So don't worry about that. Our output, we really don't need to assign anyways. Like we can't because we're updating that based on the task. So it's marked out, but we can listen to it inside of other tasks, which is what we're going to do. And since we don't have any input tasks or customization, we don't really have anything to mess with. We just attach it and it goes because it just does a component search inside of the task. So we're good. We don't need to plug anything in. So I'll compile save. Now for our transitions, let's set those up. We're going to click on idle, and inside of idle, remember what we typed out. If our actor count is greater than 0, meaning that we're just sitting around and then it overlaps an actor, so our actor is 1 or more, then we want to transition out. So we already have our task running. It's always running because it's global. Let's watch the actor count out, right? We're going to watch this integer value and then we'll do a conditional check on it. On our transitions over here, so we already had our delay task. First, we're going to remove our delay task since that was just for testing. We're going to actually do it the right way now. So delete our delay task. And inside of our transitions, I'm going to change this from onStateCompleted to onTick. Now, anytime we're using onTick, we do want to consider if we really need to. I will tell you I'm using onTick for now, but later on in this series, we're going to go back and we're going to optimize and replace this because we really only want to check the value when the actor count is changed. For now, just for learning purposes, we're going to use onTick. So onTick, we want to check for a condition. Hit the plus button on our condition. We want to compare an integer, right? So if our integer actor count is a number, so we want our int compare. So go down to integer compare. And it's kind of a weird little menu here, but you can see the results at the top here if you need like a little condensed version. So 0 equals 0. Yeah, that's always true. So we need to change that. So our left is our input. So we need to watch a value and we want our left to be our actor count. So click this little bind button over here, scroll up to SCT get overlap actor count and watch the actor count. So we're watching this value. If this value, so our actor count is equal to, we want to change that to greater than 0, then we want to transition to syncing. So onTick, watch for this condition. Whenever this condition is true, transition to syncing. So that's essentially what we're doing here. All right, let's do the next one. And you can actually see our diagram gets updated, which is a really great feature of State Tree. Click on syncing. Again, we want to remove our delay. So right click our delay, delete, and we're going to change our onStateCompleted to onTick. We're just going to watch it every tick. Again, we will optimize that later. Transition to rising, but we want to base it on a condition. So hit plus, and then we want an integer compare. For our input, we want to change that to our get overlap actor count. So when we're syncing, we want to go to rising. If our actor count ever hits 0, right, equal to 0, then we want to make the transition. So we didn't really need to change much with that, which is great. And then the last one, rising, same thing, remove the delay. So right click the delay, delete, change onStateCompleted to onTick. We're just going to watch it constantly for now. We'll actually return to syncing with this one, right? Because to return to idle, we need to do our movement comparison, which we haven't done yet. So onTick, return to syncing if we meet a certain condition. So let's hit the condition, integer compare. So to go from rising to syncing, we want our actors to be greater than 0, right? If we have actors on our platform. So on input, let's watch the actor count again. And if we are greater than 0. Okay, so just double check all these things. I know I did a lot of little steps here, so just make sure you didn't forget anything. But what should happen if you compile and you save is we should actually see our states changing. Now, our platform is not going to move because we haven't told it to move yet, but we should see our state changing. So it's idle. On top, we're syncing. We jump, we're rising. Land, we're syncing. Rising, syncing. We're never going back to idle because we've never made that transition yet, right? In order to go back to idle, we have to test our positions. But for now, just testing the actors, we are transitioning through our different states based on if we are overlapping actors or not, which is actually functioning correctly for our states.